Betelgeuse is not a star. Not in the way you think it is. What's hanging in the shoulder of Orion right now, that warm orange dot you can see with your naked eye on any clear winter night, is something far stranger. Something dying. Something coming apart at the seams. And something that, depending on how the math shakes out, may have already exploded. For as long as humans have looked up, we've taken Betelgeuse for granted. We built constellations around it. We named it. We assumed, the way we assume the sun will rise tomorrow, that the same red point of light our ancestors saw would still be there for our grandchildren. That assumption is starting to look very, very fragile. Because in late 2019, Betelgeuse did something it had never done before in recorded history. It started to vanish. Not all at once, but unmistakably watched by every serious telescope on Earth. What followed is a story that's still being written, and it's forcing astronomers to throw out half their textbooks. There's one detail buried in the data, a possibility nobody wants to say out loud that we'll come back to before this is over. First, the basics. Betelgeuse sits about 640 light-years from Earth in the constellation Orion, marking the hunter's right shoulder. To the naked eye, it looks like one of the brighter stars in the night sky, usually somewhere in the top 10 depending on the night. It's red. Most stars look white or blue-white. Betelgeuse looks like a glowing ember. That red color is your first clue that something is off. White and blue stars are young and hot, burning fast and clean. Red stars are the opposite. They're cool by stellar standards, around 6,000 degrees Fahrenheit on the surface, and they're almost always either very small and stable or very large and unstable. Betelgeuse is the second kind. It's a red supergiant. That word doesn't really do the size justice. If you took Betelgeuse and dropped it where the sun is right now, it would not just engulf Mercury, or Venus, or Earth. It would swallow Mars. Depending on which size estimate you trust, it would reach somewhere between 2/3 of the way to Jupiter and all the way past Jupiter's orbit. Hundreds of millions of miles of glowing plasma extending out from where the center of our solar system used to be. Stand outside on a summer night and try to imagine a single object so vast that if you put it where the sun is, you and your house and the entire planet would be deep inside it, with hundreds of millions of miles of churning red matter still extending outward in every direction. That's what's hanging in Orion's shoulder, and it's not stable. It pulses, it heaves. The surface boils like a pot of tomato soup the size of a solar system. Convection cells the size of 1,000 of our suns rise and fall in slow, irregular waves. There is no calm Betelgeuse. There never has been. What you see when you look at it is a star in its death throes, just at a pace too slow for a human lifetime to register. Or so we thought. In October of 2019, astronomers started noticing something. Betelgeuse was getting dimmer. Not a little, a lot. By December, it had dropped noticeably. By January and February of 2020, it had lost roughly 2/3 of its visible brightness. To anyone looking up at Orion that winter, the shoulder was wrong. Visibly wrong. You didn't need a telescope. You needed eyes. This had never been seen before. Betelgeuse is a variable star, meaning its brightness fluctuates on a regular schedule. There's a roughly 400-day cycle. There are also longer cycles layered on top of it, but none of those cycles, in any combination, produced what happened in early 2020. Something else was going on. The astronomical community went into something close to a frenzy. Papers were rushed, telescopes were redirected, theories piled up. The most dramatic one, and the one that lit up the internet, was simple. Betelgeuse was about to explode. A red supergiant goes supernova at the end of its life. It collapses, it bounces, and it explodes with a brightness that can briefly outshine an entire galaxy. Astronomers have always known Betelgeuse would do this. The question was always when. And now, watching it dim in real time, the answer suddenly seemed to be soon. Soon, in astronomical terms, can mean tomorrow or 100,000 years from now. But for a few weeks, watching that bright red point of light fade out of the winter sky, it didn't feel like that. It felt like we were watching the final seconds of a countdown. People sat outside in the cold and looked up at Orion the way you'd look at someone you loved who was about to die. Then it came back. By April of 2020, Betelgeuse was re-brightening. By summer, it was back to its normal range. The death watch was over. Mostly. But the question of what just happened was wide open, and the data we collected during those months, the spectra, the imaging, the brightness curves, contained a problem. A specific, technical, deeply uncomfortable problem that the standard models of how red supergiants behave could not explain. Not without help. Not without an additional ingredient nobody had accounted for. There were two leading explanations for the great dimming, and the truth turned out to be both of them at the same time. The first was a cold spot. Betelgeuse's surface isn't uniform. It has those massive convection cells rising and falling, and one of them may have come up to the surface, lost its heat, and produced a vast, cool, dim region facing Earth. A single dark patch the size of multiple suns would dim the whole star from our viewpoint without actually changing how much energy it was putting out. The second was dust. Red supergiants are messy. They shed huge amounts of material into space, a constant slow bleeding of their outer layers. Most of this gas, once it cools, condenses into dust. If a thick enough cloud of dust formed in the direction of Earth at the right moment, it would block a chunk of Betelgeuse's light without the star itself doing anything dramatic. By 2021 and 2022, careful work using the Hubble Space Telescope and a network of ground-based observatories had pieced it together. A massive plume of plasma had been launched off the surface of Betelgeuse, hundreds of times larger than any flare the Sun has ever produced. As that plasma cooled, it formed a dust cloud. At the same time, the patch of surface that had ejected the material was now cooler than its surroundings. We had been looking through a dust cloud at a cold spot at the worst possible angle. That's why it got so dark. Which sounds like an answer. It isn't. It just shifts the question. Because the next thing astronomers wanted to know was simple. Why did Betelgeuse suddenly throw off that much material? Stars don't normally spit out a chunk of themselves equivalent to the mass of several moons in a few months. Something was driving it. Something underneath the surface. Something the standard models had not predicted. Standard models of how a star like Betelgeuse should behave at this stage of its life are clean, slow, almost peaceful. What we watched in 2019 was none of those things. It was a star in convulsion. And as more data has come in over the past several years, the picture has only gotten weirder. Fast forward to 2023. Betelgeuse was doing something else strange. Its brightness began oscillating on a cycle that didn't match any of its previously known patterns. A new pulse, faster than the 400-day cycle, started showing up in the data. And it had a particular shape. There's an old result from telescope observations going back decades that Betelgeuse rotates absurdly fast for a star of its size. A red supergiant should rotate slowly, the way a figure skater spreading her arms slows down a spin. Betelgeuse, when scaled to its enormous size, was rotating at speeds that simply shouldn't be possible from the physics of normal stellar evolution. Astronomers had a name for this awkwardness. They called it the Betelgeuse rotation problem. For years, the leading explanation was that we were misreading the data. The convection cells on the surface were moving so violently they could be faking the appearance of fast rotation, depending on which side of the star was bubbling up at the time of measurement. That was a workable theory, but it was a theory of denial. It assumed the apparent rotation wasn't real because the math made no sense. Then a different theory started gathering steam. What if Betelgeuse isn't alone? What if there's something orbiting it? Something close? Something that has been quietly hidden inside the glare of the supergiant for the entire history of human astronomy? A companion star, a second body, threading its way around Betelgeuse on a tight orbit, lost in the brightness of a far bigger neighbor. The hypothetical companion got the nickname Betelbuddy. Cute name. The implications were not cute. If it existed, it would explain the strange new oscillation. It would potentially explain the rotation issue, and it would complicate every prediction about when exactly Betelgeuse is going to die. Then it came back. For a long time, Betelbuddy was just math, a best guess assembled from decades of light curve data, with two competing teams predicting slightly different orbits and masses for the unseen partner. Nobody had ever actually laid eyes on the thing. The problem was geometry. Betelgeuse is so bright that anything close to it vanishes into the glare. Imagine trying to spot a candle held next to a stadium floodlight from miles away. That's the kind of contrast astronomers were fighting. Then, in December of 2024, a team led by Steve Howell at NASA Ames pointed an instrument called Allo-Peak at Betelgeuse. Allo-Peak sits on the 8-meter Gemini North telescope in Hawaii, and it's designed for exactly this kind of impossible job. It takes thousands of ultra-fast snapshots, each lasting only 1/100th of a second, then stacks them in a way that erases the blur from Earth's atmosphere. The final image lands at the absolute physical limit of what the telescope can resolve. The team chose their date carefully. If Betelbuddy existed and orbited along the predicted path, December 2024 was the moment it would be at its maximum apparent distance from Betelgeuse. The best window any astronomer was going to get for a clean view. The same instrument had been pointed at the same target back in 2020, during a phase when the companion should have been hidden behind the supergiant from our line of sight. As expected, the 2020 images showed nothing. The 2024 images did not show nothing. There was a faint dot, slightly bluer than Betelgeuse, sitting at exactly the predicted angular separation and position. After decades of theory, Betelbuddy was real. Follow-up X-ray and ultraviolet observations, released in 2025, sharpened the picture even further. The companion is a young star, about 1.5 times the mass of our Sun, almost certainly a pre-main sequence object, which means it hasn't even started fusing hydrogen in its core yet. In stellar terms, it's a baby. And that baby is orbiting close enough to Betelgeuse that it's actually embedded inside the supergiant's puffy outer atmosphere, drifting through gas 100 times thinner than the air in your living room. That detail matters. A young star inside the atmosphere of a dying supergiant is not a stable arrangement. The companion is being dragged through Betelgeuse's outer layers, losing energy with every orbit, slowly spiraling inward. Estimates suggest that within tens of thousands of years, Betelbuddy will fall all the way in. It will be swallowed by the supergiant, possibly feeding the very angular momentum that has had Betelgeuse spinning too fast for so long. The next chance to study the pair comes in November of 2027, when the companion swings back out to its greatest separation. By then, astronomers will have a much sharper picture of the orbit, the mass, and how much this hidden second star is contributing to Betelgeuse's increasingly strange behavior. All of which brings us to the part of the story that keeps people up at night. The reason Betelgeuse is on the news every few months. The reason your friend, who hasn't thought about astronomy in years, texts you saying, "Did you hear? Is it going to blow up?" Betelgeuse is going to explode. That's not opinion. That's not theory. That's an inevitability written into the physics of how massive stars die. Anything between about 10 and 20 times the mass of our Sun, given enough time, will eventually exhaust the fuel in its core, collapse under its own weight, and detonate. Betelgeuse is in that mass range. The fuel is almost gone. The clock is running. The hard part is the word almost, because almost in stellar evolution covers an enormous amount of time. Estimates of how long Betelgeuse has left range from immediately to about 100,000 years. Some of the more recent papers, based on the strange behavior of the past 5 years, have argued the window may be tighter than that. Tens of thousands of years rather than hundreds. Some of them have gone further. A small handful of astronomers have looked at the violence of the 2019 ejection, the new pulsation patterns, and the confirmed companion star, and quietly raised the possibility that Betelgeuse may be in the final stages of core silicon burning, which is the very last stage, the stage that ends in collapse within a few months.
That is almost certainly not what's happening. The odds are still overwhelmingly that Betelgeuse has many thousands of years left. But almost certainly is doing a lot of work in that sentence. Nobody has ever watched a red supergiant in the days before it died. Nobody knows what the warning signs really look like, because every supernova we've ever observed was found after the fact, when the light from the explosion reached us. We have no playbook for this, and the geometry of the situation is uncomfortable. Betelgeuse is 640 light-years away. That number isn't trivia. That number is the time delay between something happening to Betelgeuse and us finding out about it. When you look at Betelgeuse tonight, you are looking at light that left it 640 years ago. The Betelgeuse you can see right now in the sky above your house was alive during the 100 Years' War. When Betelgeuse finally lets go, the show will be unlike anything in human history. The light from the explosion will reach Earth as a sudden, impossible brightening of a single point in the constellation Orion. Within hours of first detection, Betelgeuse will be visible in broad daylight, a hard white-blue spark hanging in the sky where the red shoulder used to be. It will be brighter than the full moon. It will cast shadows at night. For the better part of 3 months, it will be the second brightest object in the sky after the sun. Then it will fade, slowly. Over the course of a year or so, the brightness will drop, the color will shift, and the apparent point of light will settle back into the range of normal stars. But the constellation Orion will be missing a shoulder, permanently. For the rest of recorded human history, what we will have witnessed is the death of a star in real time with our naked eyes, and the birth of one of the most extreme objects in the universe. When Betelgeuse collapses, the core of the star will compress to a sphere about 12 miles across, roughly the length of Manhattan. All those millions of miles of churning red plasma will be gone, blown outward in a shockwave moving at thousands of miles per second. What remains, sitting silently where the supergiant used to be, will most likely be a neutron star. A neutron star is one of those things the universe builds when it gets bored of normal physics. It is the leftover core of a massive star, crushed by gravity until atoms themselves break down. Electrons get shoved into protons. The whole thing becomes a single ball of neutrons packed together so tightly that a teaspoon of the material would weigh about 1 billion tons. The gravity on the surface is over 200 billion times Earth's. If you somehow stood there for the millisecond before you were destroyed, you would not see anything resembling normal reality. And in some scenarios, depending on the exact angular momentum of Betelgeuse and the energy contributed by its companion, The leftover might not be a neutron star at all. It might be a black hole. The supergiant in Orion's shoulder might, in its final moment, collapse all the way down into a singularity. And we would watch it happen with no idea until the light got here. You'd think a supernova that bright, that violent, that close would be dangerous. People ask this constantly. Will Betelgeuse going off hurt the Earth? The honest answer is almost certainly no. 640 light-years is far. A regular supernova's most lethal effects on a planet, the ozone destruction by high-energy radiation, the stripping of the upper atmosphere, only reach out about 30 to 50 light-years from the source. Beyond that distance, the radiation arrives too thin to do real damage. Betelgeuse is more than 10 times farther than that. The one scenario that can stretch the danger zone way out, sometimes to thousands of light-years, is a gamma-ray burst. A GRB happens when a dying star's core collapses while spinning so fast that the resulting jets of radiation get focused into narrow beams along the rotation axis. If one of those beams happens to point at Earth, it can shred ozone from clear across the galaxy. The catch is that GRBs need very specific stars to produce them, mostly Wolf-Rayet stars with extreme rotation, and Betelgeuse is not one of them. The consensus is that when Betelgeuse goes, it will be a standard Type II supernova. Bright, violent, beautiful, and absolutely no threat to Earth. So we should be fine, probably. The neutrino pulse from the explosion will pass through Earth and through your body, but those particles barely interact with matter at all. You wouldn't feel anything. The cosmic ray flux might trigger a brief uptick in auroras at high latitudes, the kind of thing pilots and astronomers would notice and the rest of us would miss. The danger is not physical. The danger is psychological. Try to picture seeing it happen. You're taking out the trash on a Tuesday night and you notice there's a new star in the sky brighter than the moon. You stand there in your driveway in suburban America, holding a garbage bag, and you know, in your stomach, that you are watching a death so violent that its light has been traveling toward you for longer than your country has existed. The math says you're safe. Your body will not believe it. Which brings us back, finally, to the detail nobody wants to say out loud. Betelgeuse is 640 light-years away. Light from Betelgeuse takes 640 years to reach Earth. There is nothing in physics that lets us see a star in real time across that distance. Whatever Betelgeuse is doing tonight, we will not find out about it until the year 2666. And that means we have no real idea what the actual state of Betelgeuse is right now. The version you can see in the winter sky is a recording, a 640-year-old recording. The light hitting your eye left Betelgeuse around the year 1386. Geoffrey Chaucer was writing the Canterbury Tales. Europe was still digging out from the Black Death. The 100 Years' War had another 67 years left to run. The Great Dimming we watched in 2019? That actually happened around the year 1379. The brightening that followed? Around 1380. The pulsation oddness we've spent the last few years arguing about? That was the 1380s. We have been watching the medieval life of a star and calling it current events. So when astronomers say Betelgeuse might explode soon, they are saying something stranger than it sounds. They are saying it might explode soon in our timeline. They cannot say anything about Betelgeuse's actual timeline because we don't have access to it. The truth is that Betelgeuse, the real Betelgeuse, may have exploded in the year 1500 or 1800. Or 1962. The light from its death is, right now, somewhere out in interstellar space, falling toward Earth, perhaps 100 years away, perhaps 1,000, perhaps tonight. That's the part of this story I keep coming back to. We are not really watching Betelgeuse. We are watching a memory of it, lit by light that began its journey before our great-great-great-grandparents were born. Whatever it is going to do, it has already done. And one night, sometime in the next few decades, or the next few thousand years, someone will look up. They will be doing something ordinary, walking out to their car, letting the dog out, looking for a constellation they remember from childhood. And they will see, in the sky where Orion's shoulder used to be, a brilliant white-blue spark that should not be there. That moment, for them, will feel like an event. It will not be. It will be the arrival of news. News that left a dying star a long, long time ago, and finally, after all that travel, after all that silence, finally found us. Thanks for watching, and I'll see you in the next one.